In this exercise, we show that if x is an isolated point of S, then x is in the boundary of S. We begin with the assumption declaring x to be an isolated point of S. Then, definition 3.4.14 tells us that x is not an accumulation point of S. The diagram compares three different points. We have an interior point, which is also an accumulation point, because any neighborhood that is drawn around that point contains another point of S. Here we have a boundary point situated on what I like to call the skin of the apple. Where are the sets of the apple? This is an accumulation point because, again, any neighborhood that is drawn around it is going to contain a point of S. It's a boundary point because that same neighborhood is going to contain at least one point not in the set. And here we have an isolated boundary point. Since x is not an accumulation point, there exists a deleted neighborhood of x that does not contain a point of S. And here I've demonstrated I can draw a neighborhood around it that, other than x, doesn't contain any points of S. Hence, the intersection of that deleted neighborhood with the complement of S is non-empty. Now, by definition, since x is an isolated point of S, x is an element of S. Therefore, for every neighborhood of x, the intersection of that neighborhood with the set is non-empty because it contains the point x, which is, as we've seen, an element of S. And the intersection of that neighborhood with the complement is non-empty, which is the very definition of a boundary point.